Nick Huggett, who is a distinguished professor at the University of Illinois, Chicago. Nick works in the philosophy of science and the philosophy of physics. He has written extensively on many topics in philosophy of physics, from the foundations of quantum mechanics to quantum field theory to the theories of space and time in contemporary physics. I will mention just a few of his books. He has edited various books in the philosophy of physics, such as Physics Meet Philosophy at the Planck Scale, Philosophy Beyond Space-Time in 2021 with OUP. He has also written Everywhere and Everywhen with OUP, also in 2010, which is an introduction to the philosophy of physics, and more recently, Out of Nowhere, The Emergence of Space-Time in Quantum Theories, with Chris Wüthrich, published with OUP in 2021. Today, Nick will be talking about the physics of memory.
Talking about historical case study in philosophical conversation, GBS, Haldane, and Julian Huxley's social values in the scientific worldview. So you're all welcome for Alison's talk on Tuesday here at the center. There is no talk on Friday next week, but we are organizing the Senior Visiting Fellow Conference organized by Arnon Levy right here on science and values, revitalizing science and values, starting at 1 p.m. on Friday and ending on Sunday. On the morning of that conference, there's a pre-conference with some talks by graduate students if you also happen to be interested. Today, it's my pleasure to introduce, for many of you, reintroduce Nick Huggett, who is distinguished professor at the University of Illinois, Chicago. As nearly all of you know, Nick works in the philosophy of physics. He's worked on a range of different topics and has published extensively on all of these topics, so I won't go through the long list. No, I insist. His work on quantum field theory, but more recently his work has been, he's done a lot of work on space and its relation with quantum theory. I just will mention two books that he's published recently. One is an edited collection, Philosophy Beyond Space-Time, Implications from Quantum Gravity with OUP. 2 years ago, I believe, or 3 years ago, something like that. And the other one is a monograph, Out of Nowhere, The Emergence of Space-Time in Quantum Theories of Gravity, also with OUP and with Chris Wüthrich.
Not actually published yet, but it is. So Chris has like 1 or 2 more paragraphs, right, which I've been squeezing out of here.
Google Scholar is lying. So I was surprised that I was
there
thinking.
are chapters available.
Okay, so Google Scholar says 2021. So
that's when we put some things on the archive.
okay, all right. Forthcoming books then, hopefully
just needs to write this.
You can send straight an email to Chris, anonymous.
No, it's no time to read your email.
I see. And Nick was also a senior visiting fellow here at the center in 2021-22. Unfortunately, he is not quite the right word because it was during COVID. So here is a more of a conceptual matter. We spent a year seeing each other online 3 times a week or something like that, which was good, but not nearly as good as it should have been if you had been here. So we should talk about that today.
Yeah.
All right. And today, Nick will be talking about the physics of memory. Thanks for coming.
Right. So yes. So thank you very much for having me here. So I sort of discovered in the last few days that this paper was not as sort of polished and didn't quite get to the place where I thought it was going to. So I sort of, it's best never to apologize. I forewarn you of that. And I would very much like your thoughts at the end about whether this can go. I mean, I'm still happy giving it because I think there are some useful things that I want to say that I hope will be good as well. The paper is actually a response to David Albert's Time and Chance, which is nearly 25 years old. And it was really provoked by reading that book back then, and I've been thinking about this and perhaps giving versions of this talk for 20 years or so you might have expected it to be a bit more polished, but it came out in a volume of responses to David's book that itself took 10 years from sort of conception to appearance for various reasons. And I think only recently have I actually come to understand David's response. And I think it's not quite so clear to me now. How to deal with it. So if you thought about David's stuff, David's work, I mean, probably some people are positive about it. I would not be surprised if some people are quite negative about it. But I do want to kind of approach it with a sort of trying to be I'm actually quite sympathetic with many of the sort of impulses that he has and things that he does. But I want to try in any way, try and approach it in a sympathetic point of view and try and do something positive, see where that takes us. And that's kind of what the paper was. I find the arguments tend to either be very specific or very general, and it's sort of hard to find a middle ground. And the specific stuff seems often quite right, and the general stuff seems quite astonishing, and somehow finding the middle ground where I want to kind of engage can be a hard task. I think that's sort of reflected in this work. But what I was trying to do was trying to make some things sort of more concrete and sort of see how the arguments that he was trying to, that he sketches how I thought they should be going. I hope in the process that it clarifies some ways of thinking about these issues. I thought, once I'd done the clarifying, that I actually had a sort of refutation of some of the things that he says. That now is the part that's less clear to me. Oh, right. So this is the slides. I should have said that at the beginning. So if anyone wants to sort of follow the slide, you should take a quick picture of that. You'll be able to see it. Okay. All right. Well, let's get into it. So that's why we don't have the cursor to get rid of that. Okay. It is, you can get it over here, or maybe you can delete it. If you've got the cursor there, you can get rid of this. It's still here. Okay. So anyway, past knowledge in time and chance. So I apologize for people who've never sort of read or thought about this. I understand there was a reading group about it last semester. Some people will have done. In some ways, things are quite familiar, but it's going to be quite quick. So here's something that Albert says in Time and Chance in the chapter on the past knowledge. So everything we know of the past and present and future history of the world can be deduced from the following four elements: what we know of the world's present macro condition and of our own brains, perhaps, the standard microstatistical rule, the dynamical equations of motion, the past hypothesis. And I've got the sort of standard picture of how to think about this. So here's the sort of phase space of the universe. This is the region picked out by the current macro state. As we know, if you just wind back, if you just condition on the current macro state and say the standard microstatistical rule, namely uniform probability, if you evolve that backwards, you think about evolving all the microstates backwards, you have an increase of entropy to the past, so you end up with a vast region phase space in the initial state. So what one does to sort of actually to make sense of the world in general is impose a past hypothesis, specify some much more specific macro condition, and then all the micro trajectories have to run through here. So that's the general sort of pretty standard picture, turned here into a story about past knowledge, not just about sort of the increase of entropy and other temporal arrows. So, but particularly about past knowledge. So, if this is true, since it depends on a past hypothesis and not a future hypothesis, it's not surprising that there's an asymmetry in our knowledge about the world. It's not very clear how it sort of explains that asymmetry and what it is about us that kind of leads to that thing, but there certainly will be an asymmetry. So normally we're thinking about the physical constant, the physics of the world. We're interested in the increase of entropy, but here we're interested in knowledge, and so this gets included as well, knowledge of our own brains, perhaps. And why do we need to include that? So actually, Albert doesn't go into this in, I don't think actually gives a real explanation of what's going on here or why this is, but it's fairly clear, and part of the paper was to sort of spell that out. So here's a kind of case that makes you realize you're going to have to say something about our brains as well to understand our knowledge. So this is a pachinko machine. So you drop things in at the top and they bounce off these pegs and then they end up somewhere randomly at the bottom. So we imagine a case in which the ice cube bounces around. It ends up in the left-hand side. There's an observer, watching the experiment. They see it falls on the left-hand side. And then they sit there and the ice melts and the ice evaporates. And you get to a case where now all the beakers are effectively empty. There's no macroscopic traces in the world left of where it fell. Nothing else has kind of happened here. Okay. So if all you did was condition on the macro condition, that contains no, that's the same as if the ice fell left or if it fell right. And the microstatistical rule, the dynamical equations and the past hypothesis, it's just equally likely to have fallen left and right. There's no kind of trace of that left in the world. Yet, of course, there was somebody there. They saw it fall left, so they knew it. They know what happens. So unless we include something about our brains and the fact that there's somebody there remembering, this will just be false. So there we go. Just sort of say those things. So there's a footnote where he elaborates a little bit more on what's supposed to happen here. So we're supposed to also condition not only on the current macro state, but the present, perhaps microscopic condition of the brain, accessible by direct introspection. So something about the brain that also gets included in these conditions, and that seems fair enough if we're thinking about knowledge, because somehow we do conditions, that's where knowledge comes from. So in memory. All right. So that's the first sort of clarification, is sort of a discussion about why we need this part about the brains and how to think about that a bit. So, as I sort of indicated at the beginning, what I thought I had at some point in the paper, some version, of the paper at some point is sort of a refutation of that claim of Albert's recipe there. An example where our knowledge would outrun that apparatus. So how does he sort of back up that claim? So the asymmetry, when he's sort of thinking about it and why we arrive at this asymmetry, comes from reflecting on records. So the basic idea is, if I know the state of something in the past, and I know the state of it now, I have a lot of information about what's happened to it in the intervening time. Much more than if I just know what it's like now. There's many different possible pasts that it could have had that got it to the present state. But if I know what it was like previously, I know which one of those paths it's just taken, and that gives me a lot of information about that system. So what's happened to it, and then information about all the things that might or might not have been interacting with it as well. So that's the basic picture. That's how we get knowledge of the past. We have records from the past. We have that sort of knowledge about past states, and we don't have a corresponding knowledge about future states. So, and of course, ultimately, he's going to see that going back to the past hypothesis. So to explain that asymmetry. So, fair enough, and it is going to be an assumption of the talk that records are the key thing here. I'm going to be working with that idea. But here's the argument, and this is what I found the most puzzling in the book, was this sort of argument puzzles about how we ever managed to come by information about the ready state of a record-bearing system. It can't be by means of retrodiction prediction. It must be because then there's only two possibilities. Either there's either we have knowledge of the past by records or by retrodiction. But this is supposed to be replacing retrodiction, so it can't be that. So the only thing it could be is that we have a record of that other condition. But how is it that the ready condition of this second device is established? And so on, obviously ad infinitum. There must be something we can be in a position to assume about some other time, the mother, as it were, of all ready conditions. And this mother must be prior in time to everything of which we can potentially ever have a record, which is to say, it can be nothing other than the initial macro condition of the universe as a whole. So that's basically the argument he gives for getting to the recipe for that condition that I put up earlier, about what it is we can know about the history of the world. So, I actually remember sitting on the bus and reading this and just being profoundly puzzled by what's going on, because there seemed to me something very right about the business about records, but something very obviously has really gone off the rails if you take this sort of seriously. Okay, there's this regress argument, okay? And it seems like if that's how we know about the past, we would have to know we have to know the past hypothesis to know the past, but we do know the past and we don't know the past hypothesis. So what's going on here? This seemed to me paradoxical, and everything that follows really came from puzzling about that. So, what I would say really is this is sort of a reductio of the idea that memory is somehow explicit record reading, since it would require us to know the past hypothesis in some sense, and I don't think that's plausible implicitly or explicitly. So that's what I would draw from this conclusion, from this argument. And I would say, I think the term know gets used quite loosely in these discussions, and it's not clear what it would count. Sometimes it's explicit, sometimes it's implicit. And when you start thinking about implicit knowledge, it becomes especially shady about what that would actually sort of amount to. But it seems, in many senses, we don't know the past hypothesis. We do astrophysics and cosmology to learn about the early state of the universe, and not psychology. We don't look at, if we knew it somehow, even implicitly, it seems we could learn about the past of the universe through psychology. And maybe that's true, but that seems not implausible or problematic. All right, well, let's take it then that this shows that this sort of picture of explicit record reading is not a good model for memory. There's sort of, as you'll see, other good reasons for thinking that's the case in just a minute. How then does memory work? In a way that sort of gets at something about its sort of physical basis, and that might be useful for the kinds of discussions that Albert wants to have about knowledge asymmetry. And since this is Albert's argument for the recipe for what we can know, if memory doesn't work in this way, that does open the possibility that memory might do better than the recipe. Okay. So just to remind you, I sort of been implicit what I was saying. What the argument was supposed to show is that the recipe sort of captures all our knowledge. That's the argument. I've heard David give this in talks and sort of asked him about this, and the thing I've heard him say is, well, no, I don't mean it seriously. This is sort of suggestive of what's kind of happening. So I may leave it at that. I've been reading the After Physics recently, and I think there's another idea he has more recently about what might be going on here. But I have not yet wrapped my head around it. I think it's the right thing to say. So here's what I want to suggest for a better way of thinking, about memory in a concrete way. And this is using Murray Gell-Mann's idea of an information gathering and utilizing system, an IGUS. This is from a paper by Harkle that draws on this idea, but it's a nice kind of picture. So we'll talk about the gathering first. So this is some receptor that the machine, that the IGUS has. This is the outside, the box shows the exterior of the IGUS. So there's a visual stimulus in this case, and A is input. And the thing that's going to happen next is the A is going to be stored in P0. Well, before that, well, whatever was in P0 will have been moved to P1 and P2 and P3. So this is something like a short-term memory that it has, and stuff shuffles. As inputs come in, a representation is stored and it's shuffled down the short-term memory. And then, important for Hartle's paper, something because of the shuffling, there has to be a raising at some stage. I'm not going to talk about that, but that's where he gets an arrow of memory from. Okay. So, but what also is kind of going on here is there's an internal unit that's looking at the contents, taking as inputs the contents of the short-term memory and producing at each stage a schema, something like a model of the world. So, you know, all of our sort of inductive inferences, for instance, long-term memories would be sort of as well, would sort of be in here, and the result of the inductive inferring would be in here. And then whatever theory we sort of have of the world will be stored in the schema is the general kind of idea. So that's the information gathering. But then there's also utilizing. That's governed by this computation in the box C. That looks at what just happened. So that's P0. And it looks at the schema. What do I think the world would like? Makes some decision about how to behave, which then leads to an output of behavior. So that's how it utilizes. So it's a pretty simple kind of natural picture of what's going on. So it's very simplified, but I would say sort of not too simplified. And it seems to me because it, you know, is responsive to inputs and it's capable of behaving, this seems a nice kind of model that has the sort of essential features for something like us that's taking in information, processing it to come up with knowledge, and then acting on that knowledge. It has the kind of key features that we want for this system. But of course, you know, Hartle and Gell-Mann are interested in this because it has it's a pretty clear physical realization of how you would do this, and you can start to think about physics. So the next bit of the discussion is about, you know, what happens when the IGUS remembers. I'm going to think about it from a computational point of view. At some points, we'll put back in the physics in a natural way. So the particular case I'm thinking about is it could be shown an A or it could be shown a B. That happens at the first time. It's updating in here. Okay. At the second time, this card has a question mark, which it interprets as a question. Did you see an A? Right. And then it says the behavior does its stuff, and then the behavior is either it says yes or it says no in some way. So it's going to remember what it's just seen. That's the general picture. Here it only kind of cares about really the contents of, well, yeah, it's sort of dependent on the contents of P1 in this case. Because when it's asked, there'll be a question mark in here. A representation of A in here. So I'm going to use that case I'm going to give you sort of two conditions on what it would be to be a good sort of mnemonic system, an IGUS that can be really thought of as remembering what one would expect it to look like. So that's why there's a 1 here. And the first thing is reacting directly to Albert on the explicit record reading. And the point is there will be implicit record reading is really what's going to happen. Okay. So the first thing you might have thought, and perhaps sitting on the bus 20 years ago, 25 years ago, this is what I sort of had in mind, was trying to kind of cram Albert's picture into, and it seemed really problematic. That it would engage in some sort of explicit register reading. So it would sort of look at its own current state, I guess the schema or what's in the registers. Maybe we'll focus on the registers, but the schema itself is a register as well. Okay, it'll sort of condition on the current state of its registers, or represent its current state of its registers, represent the sort of initial state of the registers, somehow then factor in the schema to work out what it thinks the cause of the difference between the ready state, the initial, the ready state and the current state is, and then sort of store, pass on to this, then sort of store somewhere in here a representation of the thing that must have happened to get from the start to the second according to that computation. So somehow that computation, it maybe knows the laws for itself, so it sort of would. Right. And then it looks at what that computation is, it's, what it thinks has just happened, and then has a behavior. All right. I see some puzzled looks, and I hope that's not because that was unclear, but because that seems like a crazy way of doing things. Because, of course, what you would just say is, look, all I've really done is found, it's equivalent to just seeing what's in P and then acting as if that was the result of the computation I just did. Right? I'm just going to sort of assume that the thing was ready, so I don't have to represent that. I'm not going to bother with the computation. The whole upshot's going to be, I'm just going to act as if P1 was in some appropriate state and just act conditionally on what's in P1 and forget about this whole computation. In other words, this is what we want to happen. So here's a part of the machine table for the IGUS. And it says, well, there's a question mark in P0 because it's just been asked a question. And there's an A, a representation of A in P1, which contains a record of what happened the time before. Then I'm just going to say yes. But if it was a B, I'd say no. And there doesn't have to be some complicated computation of what explicitly what happened that involves sort of representing the current state and the initial state and the ready state. I'm just going to do this. And this is clearly far more efficient way of doing things. And that's what I say. I messed this up. I did animate it. Right. So that's it. So that I forgot my animation. So right, it stores the A. Next time it sees the question mark, that gets stored, and it just says yes. That probably didn't answer anything. I was playing around. But surely that's what's going on in memory, and not any of this kind of thinking about previous states and then computing what happened in between explicitly. None of that is going to be happening in a mnemonic system. That would be a crazy way to build one. So Albert's regress sort of just doesn't get going. There isn't explicit record reading. There's implicit record reading. Okay, so we don't need any record of the ready state at all. We just need a machine table that works when it was in its ready state initially. And if something had gone wrong so that it wasn't in its ready state, then we might not find an A in P1. Or if there wasn't some process to actually erase and move things along, there's lots of things that could go wrong. But assuming that the system actually is working correctly, this is all we need. So that was sort of the bit that got me off, the sort of step and sort of thinking about that got me past my initial reaction to the regress argument and explicit record reading and what was going on. This was kind of the side that I had. All right. So, but now we're left with the question, the argument for Albert's recipe as a condition on our knowledge of the history of the world sort of depends depends on this argument. The argument comes from the idea of explicit record reading, but I've just given an alternative to record reading, explicit record reading, which is surely what's actually going on. So we don't really have that argument anymore. And if we don't have that argument, should we think the recipe is correct? And if the recipe is not correct, can we think up a way in which we can remember things that do get beyond the recipe? So, okay. So this is the sort of second point about what a mnemonic system like this is going to have to do, or what we would expect it to do. And the idea here is I need to say a bit more about what the IGUS is going to be like, so I can sort of fit it into the recipe, figure out what it would know according to the recipe, and then see if it knows things that the recipe doesn't think are likely. And that was the thing I thought I'd done, but now I'm not so sure, as I will explain. So the IGUS is a kind of Turing machine. I mean, I guess it's one that takes an input and then sort of goes for a bit until it halts, and then takes another input and goes for a bit until it halts, something like that. But it's a kind of Turing machine. But unlike, the ordinary Turing machines we think about, it's open. It gets sequential external inputs. It doesn't just sort of take one input at the beginning and keep going. It's sort of a closed system after the initial input. It's getting inputs all the time. So it's a bit more complicated, and there's just a couple of things to think about. Of course, in an ordinary Turing machine, I mean, I know there's sort of some literature on this, but the general picture is, if you think about it, if I just know the state the machine's in now and the algorithm, what its algorithm is, there's often multiple routes that will get you to the same current state of the computer. I don't know if you think about sort of register machines, which just move balls around buckets. The current state might be all the buckets are empty, but it could have started with any distribution of buckets, and it's just spent some time kind of emptying them out. So I don't know how it started. So what we're starting to get to here is a thought about what is it that an IGUS would have to know about itself that would be an appropriate thing to fit into the recipe. There's that line where you have to condition on the current macro state, and whatever it is we know about our current condition of our brains, perhaps microscopic information. So this is sort of thinking about what it might be that you'd have to know, what would be appropriate to fit into that recipe to get something plausible out. Well, it's clearly not just going to be the current state and the algorithm. For a regular Turing machine, if I knew the initial state and the current state and the algorithm, I would know exactly what's happened to it. In fact, I wouldn't need to know. I mean, I guess I'd know. Yeah. Now I think about it, I'd have to know how long it's been running as well here. Okay. But insofar as that sort of will determine things for a regular Turing machine, it won't for the open Turing machine, because where it is not only going to depend on how it started, where it is, and what the algorithm is, but what series of inputs it's had. Of course, that's going to make the difference as well. It's basically a function with those as arguments as well. So the way it's going to have to go, if you then think about it, we need a rather special kind of algorithm for the IGUS to work correctly, because it does need, what it needs to know is what the series of inputs actually was. Right, that's what it's trying to remember. So there is going to have to be an initial ready state. In general, if it sort of doesn't start in its ready state and I try and put something in it, it's not going to be a proper representation of the implicit record reading. So there has to be an initial ready state. And then there needs to be an algorithm, well, of the obvious kind, so that given that initial state and the current state, there's just one series of inputs that could have possibly come along. That's the kind of algorithm we need, sort of ideally. Okay. You know, I mean, in reality, there could be some fuzziness, but that's basically the picture that we want. And then, of course, to be reliable, it better be the case that it reliably starts in its ready state. So that's really what we need. So these are the, so this is the second condition, and I've called this an algorithm. Having an algorithm like this, computational rigidity. I suspect there may be something in the computer science literature where this has already got a name, but I don't know. Maybe other people do. So, well, I agree with what I've said here. Being reliable wouldn't require you to know this explicitly, but it wouldn't require you to. It's not clear to me in any sense that it would be required implicit knowledge as well, other than the fact that you just acted on the assumption, as if your memories were reliable. They actually were the basis for your actions. I mean, maybe that's sort of implicit knowledge, but it seems like a very sort of attenuated kind of implicit knowledge to me. So I actually would probably just scrub the word explicit there, and I'd be pretty happy with what I've said already. Okay. The IGUS can happily go along without anything like knowledge of these being the case of itself. It's just got memories, it does its stuff, it carries on, never finds any reasons to sort of doubt that its memories are, its behavior, it doesn't get into trouble, when it acts in that way, it finds the world really is in accord with its memories, it's all good. It doesn't seem like it has to have anything like knowledge of these things. Okay. So I claim I formulated these as sort of necessary conditions up here, but I also would say that they really are sufficient. I'd be perfectly happy saying that the IGUS actually remembers that the ice fell left, and indeed that would be true. If those things are in place, and then maybe I should also say, as long as it's then actually acting in accordance with that, with the truth of its memories. Well, and if the world actually is in accord with it, then I would be happy to say that it does actually have memories, it does have knowledge of the past. And of course, it's the sort of acting that's sort of important there. It's not just records, but the way it acts on them as if they were representation of the past. But then that is the full intents and purposes memory. So the first goal, as I said, was to try to get something I felt that I could get a model or a picture of memory that I could get my hands on more concretely than I found in the book, and that's what I claim to have done here. This is a sort of more realistic picture of memory. It's still perfectly compatible if you want to be a sort of a Boltzmannian like Albert. There's nothing kind of that excludes that from what I've said. It seems, in fact, very friendly to that way of thinking. And so if you want to think of, my thought was, if you want to think about the knowledge asymmetry, you shouldn't think about explicit record reading. This is the kind of picture that you want, and I've given some parameters for how to think about it. And so having done that, I did do that. So let's come back to Albert's argument. So again, this was the recipe and this was the claim, same thing as before. Everything we know about the history of the world, past and present, can be deduced from what we know of the world's present macro condition and of our own brains, and microstatistical rule, the laws, and the past hypothesis. Deduced, this is, of course, it's a statistical rule, so deduced here means with very high probability, very close to 1 probability in most cases. There's something else going on here where sometimes the probabilities you deduce, Albert's mostly thinking about the cases where the probabilities are essentially 1 and 0. In general, there's a generalization where we're getting probabilities for everything, in which they're not just 1s and 0s, and there's a claim here about the distribution of those probabilities sort of as well. I might know that some event yesterday was 50-50 based on my memories or something like that. That ought to come out as well. I think I'm not so concerned with those cases here. Not because I mean, I think that those are problematic cases, but for simplicity. Okay. So I foreshadowed this a bit, thinking about the second condition on the IGUS. So what is it? What actually is this? What does it need to know about its own brain? What's going to have to be included by direct introspection for this recipe to actually give the things that we think are veridical? So I'm going to think about those a bit. I'm going to end up basically with a pretty maximal story that's, feed in the whole microstate of the IGUS. Okay? Even if you do that, my claim was there are things that the IGUS remembers that do not get high probabilities according to the recipe. That's the thing that David questions. Okay, so what goes on when the IGUS sort of introspects? So go back to the experiment right at the beginning where we drop the ice cube in the Pachenko machine. It kind of rattles around, ends on the left, melts, evaporates. There's no macro traces left, but the IGUS was there watching and it remembers where it fell in. Okay, well, you've got a nice little picture of it. So, as we've said, at the beginning, the upshot was once the ice cubes evaporated, the past hypothesis, the macro condition, the microstatistical rule are indifferent between it falling in the left side and the right side. So what else? What must the only thing we get to add is information about the IGUS. So what information should we add? So just knowing what's in all the registers isn't going to help, because that doesn't tell you anything unless you know what the algorithm is. What they represent is kind of meaningless, independent of the algorithm. And even knowing the microstates won't do it of the registers, because that won't tell you the algorithm either. So at that point, I wasn't kind of sure what more bits to sort of add here. So I just went straight to everything about the IGUS, so its exact microstate. Because if you know those and you know the physical laws, I think presumably that will determine what's inscribed in each of the registers, just from the physical reasoning, and it'll determine the machine table. If that's, if we're assuming sort of physicalism about this machine, then this is sort of everything. What it does is kind of encoded into the microstate. And clearly that's the most that you could possibly know about by introspection anyway, and obviously is ludicrously far more than you could possibly know. But it's maximally generous for Albert if you're trying to construct a counterexample. There just isn't anything else of the kind that he was suggesting to add. Okay, now we made this point from a computational point of view before. Now making it from a physical point of view. It's an open system. It's receiving inputs. It's not closed. I'm sort of assuming that's the only way in which it's an open system. It's not sitting in a skull, so it's not kind of it's not getting bashed by things. But there is stuff coming in through stimuli coming in through its sensory organs. So, but that's enough to say, taking the microstate and time reversing its evolution certainly again won't determine the sequence of stimuli. Just the same. Well, so that won't tell you its initial state. It won't tell you where the ice fell. But we do have this piece of information. The microstate, the physical laws, tells you what the algorithm is. So it does entail that the thing is computationally rigid. So if I condition on the current microstate and the piece of information that the registers were in the ready state, in the laws, then I do get the stimuli coming out, and so I do get the fact that it received a stimulus corresponding to the ice cube falling left. Good. But of course, the question is, where does this come from in the recipe? Well, no. That's the thing that isn't kind of, you don't get by, I agree with Albert, you don't get by sort of retrodicting. That's, if you just know how the computer is now, its exact state, and that, all you can do by winding the rules back, since it's an open system, again, it's still not going to take you back to what the ready state was. It's not going to tell you what the stimuli were. Okay. Because again, it's because it's an open system. If it was a closed system, that would tell you exactly what the history was, of course, but it's not. And what happened to it is exactly the thing we're trying to get out. Okay. So let's just sort of think about this. Where have we got to? So I've now sort of updated to make more specific Albert's recipe to say everything we know about the past and present and future history of the world can be deduced from what we know of the world's present macro condition. I'm allowing conditioning on the complete microstates of the brain, the microstatistical rule, the laws in the past hypothesis. And I will remind you what the past hypothesis is. So it's not it's not simply that the world was in a low entropy state, maybe not at all that it was in a low entropy state. It was in the highly condensed Big Bang sort of macro condition that cosmology will eventually present to us. Albert characterizes it. So this was sort of the argument then that I had. I probably shouldn't have put the response up yet, but try not to read that for a second. So I said, agreed. If I've got the recipe, that certainly makes it unlikely that the mnemonic agent, the IGUS or us, was a random fluctuation. It's not a Boltzmann brain. That's not what I'm sort of saying here. But what we need more specifically is somehow to see, since it doesn't follow, if I cut out the past hypothesis and all I have is the current macro condition, the microstate of the brain, the microstatistical rule, and the laws, I don't get it it's not clear, I don't seem to be getting that the machine started in, the mnemonic agent started in its ready state. That's the question. I certainly can't get it just by retrodicting because it's an open system. Throwing in the macro state doesn't seem to help because think about the ice cube. Something's happened, but there is no macro trace of it. It's all in the only trace of the thing is in the state of the brain. So that was the sort of thought. I can't retrodict using the brain to see what happened. I can't look at the macro state to see what happened. Okay. Albert wants to claim throwing in the highly condensed Big Bang sort of macro condition that cosmology will eventually present to us would do the trick. Now I would get that the ready state of the IGUS was very probable. It was very probably in its ready state earlier. And that's the thing that I sort of question because these things did not seem to be connected to me. So this is Albert's argument from the book. And so this is the point where I'm now trying to wrap my head around exactly what it is he's proposing and exactly how to then do that in a way to sort of engage with this argumentatively. So this is a bit more like Albert exegesis or me trying to kind of present a form of the argument with sort of premises and things that I feel I can argue against. All right. So this is what he says nicely. Well, there's a bit before that where he's a bit nicer about it's an interesting mystery. All right. We have a famous argument from Darwin, after all, about how it is that whatever IGUSes there may happen to be in worlds like ours are actually likely to have gotten here. We have a famous argument from Darwin in particular to the effect that whatever IGUS is, there may happen to be in worlds like ours, worlds that is that have evolved to their present states in accordance with the microdynamical laws and the statistical postulate over billions of years from some much lower entropy macro state, are likely to have gotten here by means of random mutation and natural selection. And IGUSes that get here like that are likely to open their eyes in the morning in some reasonable approximation of their ready states, because the ones that don't, so the argument goes, will have long since died out. Okay. So I don't want to dispute the theory of natural selection, obviously. The question is sort of what it has to do with the past hypothesis. And sort of this characterization of Darwin's argument. So this is the bit where I'm going to, I'm going to be as sympathetic as I can to try to reconstruct this argument in a way that is congenial to my mind. So the idea then is that the laws, the microstatistical rules, the past hypothesis, he doesn't mention it here, but you could throw in the current, you're allowed to throw in the current macro state if you like, entail that IGUSes got here via natural selection. If you find one, it probably came here by natural selection, which entails that it's likely fit, which would require it to be reliable. But if it's reliable, it did start in its ready state, so ceteris paribus likely has their veridical memories. So that's sort of the picture. So clearly the question is, how do we get to this first thing? How do we get to the natural selection point? I might leave that note. I'm not sure about that. So this is from After Physics, where he sort of spells this argument out a little bit longer, at greater length. And I will say this, After Physics was 2015, so I should have thought this through more carefully recently. Although the argument I gave, I wrote like 2010, and also David had seen it then, so I don't know whether he much thought about it at that time. So here's what he says. Here's how, right? So this is when you first, I don't know, how does Darwin in what way is Darwin appealing to the past hypothesis? The question here. So here's the answer, as I understand it. And the people who've been reading this, I don't know if you came up across this particular aspect of things. I would be very interested to hear what you have to say about this. The first humans are unlikely to have condensed out of swamp gas, or to have grown on trees, or to have been born to an animal incapable of fear. The first would require detailed and precise and inexplicable correlations among the positions and velocities of all the molecules of swamp gas and the surrounding air and the ground and God knows what else. And the second would require a vast, simultaneous, delicately coordinated, unimaginably fortuitous set of mutations on a single genome. And I apologize, I'm reading it with my voice and not David's voice. And the third would require that every last one of a great horde of mortal dangers will somehow conspire to avoid the animal in question, with no help whatsoever from the animal herself until she is of age to deliver her human child. And it's precisely because the account of the descent of man by random mutation and natural selection involves vastly fewer and more minor and less improbable such coincidences than any of the imaginable others that it strikes us as the best and most plausible explanation of that descent that we have. I'm not a philosopher of biology, but that sounds like a not totally terrible summary of a way of thinking about the Darwinian argument. Whether it's Darwin's or not is obviously not crucial, but what does that have to do with the past hypothesis? Nothing kind of problematic there. Of course, it's what it means to be a coincidence and by what measure we're judging these events to be likely or unlikely that the past hypothesis comes in. And questions about what does and what does not amount to a coincidence are matters on which the sort of fundamental physical theory we are imagining here, this one involving the past hypothesis and the microstatistical postulate and the laws, on which the sort of fundamental physical theory we're imagining here can by no means be agnostic. And it's part and parcel of what it is for that sort of theory to succeed, that it answers every last one of those questions correctly. So that's where the past hypothesis is coming in. Yeah, you saw I kind of put these in yellow, so it wasn't just me kind of yakking on for an hour, that there were some actual claims I was making here. I mean, the main one is that I think that, I don't know, I feel for myself at least, I've kind of clarified some ways of thinking about these kinds of arguments. But I will sort of insist the argument for the recipe is now nothing like the regress argument. Okay? This is what the argument really for the recipe or this condition on what we know has become. So it's this, right? The laws of the microstatistical rule, the past hypothesis entail our reliability as mnemonic systems because of these Darwinian considerations. They make the Darwinian story, they're part of the Darwinian story, and according to the Darwinian story, if there's a mnemonic system, it's likely to be reliable. And then because it's reliable, the memories are likely to be true, but if the memories are true, those events happened. And so if we retrodict from them and from the current macro state, then the things we're getting out of it are all going to come out to be true. That's how we get to the truth of how this story, the recipe makes it likely that the ice fell left. Well, the igus probably evolved, almost certainly evolved. It remembers the ice falling left, so the ice fell left. That's how it would get to that kind of outcome. I focused on memories. One would tell a similar story for other kinds of records. There would be other kinds of similar stories about how we read from other kinds of records. I will note, although I feel this sort of way of thinking pushes away from the regress argument to this argument, and I don't know whether my work, what I did, had any kind of causal effect in Albert shifting in this way, but it seems logically the response to the thinking about implicit reasoning and the regress sort of means that you need an argument, something like this. It doesn't actually, as it turns out, depend on the specific conditions for reliability that I went through. So, all right, I'm just wrapping up. Okay. All right, so the argument that he's given in response to what I've said, right? It relies on this: laws, microstatistical uniformity, past hypothesis, make all those other coincidences highly improbable. And the kind of argument then I think that he would be giving from other things he's said, well, let's grant that that works for thermodynamics and thermodynamics-y kind of cases, the things that are sort of close to that. So indeed, those are the cases which is supposed to work and give empirical support for the claim that this is how we get the probabilities for things, and what it is to be a coincidence then is to have a very low probability according to this scheme. And so maybe that's okay. Maybe this, there's something to what he says when he claims that the probability of humans condensing from swamp gas or budding from trees, those things seem like within the realm of thermodynamics or close to it. And so maybe they do come out to be improbable. Sort of starting response is, yeah, but we also know if you just want sort of thermodynamics probabilities, there's a lot of measures on the microstates that will give you the same thing. And in a sense, that's they're just as well empirically adequate as the uniform measure. So If you want to rule those out, you're going to need some extra empirical criteria here. But they give different probabilities for macro histories. Small micro changes can lead to big differences in the macro level. So if from that point of view, so this is now quite speculative, it's not clear that random mutation plus natural selection is vastly the most probable outcome. There may now, if you pick one of those other measures, have a different kind of probability. And I'm going to stop here. So that's sort of where I have got to in sort of thinking this through. Well, I got a little bit more, but I'm not going to put it because it really is speculative. I think we're out of time. But what I've just said here is just a special case, sort of sadly, of the question about how to think about the special sciences in this Albert and Barileur developing this, the scheme that's now called the Mentaculus, basically where this line of thought I've followed. Maybe this isn't true, but let me say for now, it sort of it seems from this thread that it kind of leads us to a familiar place sort of in the literature about how to decide this particular issue. And then I find that that's the anticlimax, I guess. A couple of slides ago, I thought I had an argument that didn't have to do any of this, that sort of showed why, you know, my IGUS could remember what happened, even though it didn't come out to be likely. But I've been driven by this sort of Darwinian argument into the mire of these issues. I would like to think the intuition again behind was, look, we don't remember by explicit record reading, but by implicit record reading, and that gives us a sort of an escape, potential escape from what Albert's said, from Albert's picture. Part of that escape is recognizing that it doesn't matter at all whether the IGUS sort of knows anything about natural selection or its own reliability. It just acts as if it's reliable, and that is enough for it to have memories. And somehow that's still an idea that I find kind of useful, and I'd like to think of a way in which that sort of idea can still sort of play a role here, but I don't know. So I will stop, and I would welcome people's sort of thoughts about this situation.
We take 1 minute breaks.
Every time.